Okay, good morning, welcome back. Happy Friday. So the plan for today is different than the plan that I gave you on the syllabus on the first day of the semester because of that snow day that we had on Monday. So we took the quest as scheduled on February 10th, and the two highlighted days are the ones that we're going to talk about. We were supposed to cover lesson number 6, which is about equations of lines. We were going to do that on Monday. Monday we were snowed out. I have no idea why. There was no snow when I got here at school at 7:30 on Monday morning, and the snow didn't start until like 1 in the afternoon. But anyway, I have no power over that. So yeah, there were lots of people here. So anyway, the plan on Monday was going to be to cover that class. We are going to cover this class today. The plan for today had been to cover lesson 7, which is additional properties of lines. We are also going to cover that today. Now these two classes kind of go nicely together. I'm going to talk a little bit faster today than normal, and you are not going to have enough time to finish the activities in class. I apologize for that, but I think we'll be okay doing the two of them in one go. I've also highlighted here in red this February 12th. The due date for the homework on lesson 6 is technically today, or at least it was. I've changed it now. This homework assignment is now going to be due on the 17th, which is our next class. So you'll have 2 homework assignments due on the 17th. I normally don't like giving 2 homework assignments at once, but our saving grace here is that Monday is Washington's birthday, and we don't have classes on Monday. And so these 2 homework assignments that we're going to assign in an hour are not due until Wednesday. So you got 5 days to do 2 homework assignments, which is like our normal kind of time period. So that's the plan, and let's jump in on page 46. So here we go, daily summary. In this lesson, we make extensive use of the slope-intercept form of a line. We also see the point-slope form of a line. Number 0 here is an important note. We are skipping sections 2.1 to 2.3 in the textbook because they cover something called functions, which is a concept that isn't part of our curriculum. From this point forward, if you see the word function in your textbook or homework, and you will see it in your homework, you are going to mentally replace that word with the word equation. If you see the word function in your MyMathLab homework, which you will, in your mind, you are going to change that word function to equation. And you're going to see funny notation, f parentheses x, or g parentheses x, or h parentheses x. Some of you already know what that means and how it's pronounced. It's pronounced f of x, but we're not worried about that this semester. If you take college algebra, you will define formally functions, and you'll talk about them in detail then. But for our purposes this semester, if you see any of these funny symbols in your homework, which you will, you're going to mentally replace those symbols with the single letter y. Also note that in the MyMathLab homework, you may have to write some equations in the form f parentheses x equals instead of our more traditional y equals. The directions will make it very clear, but you got to follow the directions. So for example, if in MyMathLab you read the following, consider the function f parentheses x equals 3x minus 2. All you're going to do is change the word function to equation, and you're going to change f parentheses x to y, and then we'll get something that is a whole lot more familiar sounding. Consider the equation y equals 3x minus 2. They mean exactly the same thing. I have no control over what MyMathLab does, so I'm just telling you you're going to have to do some substituting. All right? I will point out this note again in lesson 7, which is also happening today. So, number 1, slope-intercept form of a line. For a linear equation of the form y equals mx plus b, the slope of the line is m, which is that number touching the x, and the y-intercept of the line is b, or 0, comma b. This y equals mx plus b is something I'm sure we have all seen before. But without having that memorized, I want to point out that you kind of intuited what that formula was in a previous lesson. Remember this car depreciation problem? The car was originally worth $10,000 and it depreciated at a rate of $500 per year. Remember this problem from the other day? And I said write an equation for the value of this car after X years. And so you might have said something like, okay, it starts at 10,000 and it loses $500 per year. How do I account for the per 500 every year? We'll just put an X there, right? This is something you wrote, and you weren't thinking y equals mx plus b. You just sort of intuited that. Starting at 10,000, losing 500 every year, that's 10,000 minus 500x. Every year is the times x. And that if you prefer, you could just swap the order of these two things and make it negative 500x plus 10,000. It's exactly the same thing. And that looks just like our y equals mx plus b formula. What's the slope? Which is the m. That's negative 500. How much is the y-intercept, which is the b? 10,000. And if you take a look at the graph that you had in this problem about the car, you'll see indeed the y-intercept was up there at 10,000. All right. So here is a straightforward question, number 2. Write an equation in slope-intercept form of the line that has slope m equals negative 2/5 and y-intercept 0, 3. So here we go. I'll start with my familiar y equals mx plus b. This is going to be a simple matter of just changing the m and the b. Y equals, instead of m, negative 2/5. Copying that x, plus b instead of b, 3, because b represents the y-intercept. That's it. That's the equation of that line. Easy? Okay, they get a lot tougher. Let's take a look at number 3. Let's find an equation of the line that passes through the points negative 1, 4 and 2, negative 5 by following the process outlined below. First, do you guys buy it? Just imagine plotting 2 points. Doesn't even have to be those specific ones. How many lines connect those 2 points? 1. So this is there's a unique answer at the end of this problem because there's just a single line that connects the 2 points. The question is, what is the equation of that line? So here's the process. We're just going to do a lot of pointing. It's already written out, typed out all here for us. So it says circle both coordinates of a point on the line. If you have 2 points given to you, pick either point and circle its coordinates. So it doesn't matter which one we pick, but let's just all pick the first one. And we're going to come back to that. Part B says write down the slope of the line. Definitely have to have the slope. Well, we talked about slope in the previous lesson. Remember the slope formula is the change in what on top? Change in y over change in x. So the change in y would be 4 minus negative 5. And then if I do that order, what am I doing downstairs for the change in x? Negative 1 minus 2, right? Just be consistent. And so what we just said is right there, 4 minus negative 5 over negative 1 minus 2. We do the arithmetic. Upstairs is 9, downstairs is negative 3. Divide, and we just get negative 3, which is the slope. Next step. Part C says write y equals mx plus b. It's kind of like a silly step, but I think it's important. I think it's going to give us the space that we need in order to find the last part of this puzzle. So we're just copying it so we have it in front of us. Then it says in the equation above, the one that you just wrote that's highlighted, you replace the m with the slope and you write the equation y equals some number times x plus b. So all we're doing is changing the m to what number in this problem? Negative 3. So that m becomes negative 3. Everything else got copied down. And we're about to do a little bit of work to solve for that b, the y-intercept. This is where a lot of folks get into trouble. They recognize that the equation is going to look like y equals, let's see, m times x. M is negative 3, x plus, and then they sit there and they think, well, I know b represents the y-intercept. And they'll look at the givens in the problem, which are the coordinates of 2 points, and they'll say, how much is the y-intercept? And they'll think that they should be able to look at it and just know, and you're not. There's work involved in finding the y-intercept. So just writing plus b, calling it plus b, is going to give us the space that we need, the structure that we need in order to actually solve for the thing. But it isn't something we're supposed to be able to just look at and write down the answer. So here's how we calculate. All right, so we'll put a little star here just to make it easy to refer to. It says rewrite the equation from the previous step, but replace the x and the y in the equation with coordinates of the point that you circled in step A. So we circled one of those points. It was, what was it? Negative 1, 4. Good. So we're just going to change the x to negative 1. And we're going to change the y to 4. And we're going to copy everything else. Lots of math is about making small change, 1 or 2 small changes, and then copy everything else. That's what we've done here. 4 equals negative 3 times negative 1 plus b. and that b is to be determined. Super, I've got an equation that I can use to solve for b. -3 times -1 is +3. That's there. 4 is equal to 3 plus b. Subtract the 3 from both sides, and b is 1. And so the last thing, the final answer here, we go back to our starred equation, and we're just going to change the b to the number we found, which was 1. So the starred equation comes down here and becomes y equals -3x plus 1. And so that's our final answer down there. That's the equation. It's not a terribly complicated process. With a little bit of practice, you can get very good at this. And so I don't need to see you like on tests and quizzes, like write all the stars and circling things. I just need you to get to the answer. It's all that I need. I'm providing here a step-by-step process because actually in the beginning, until you get good at this, it's kind of tricky because some of the letters, look at the y equals mx plus b. How many letters are in that problem? 4. Some of those letters need to change to numbers, but some of those letters stay letters. Which letters are changing to numbers in the final answer? The m and the b. And which letters are staying letters? The x and the y, right? Like here's our green final equation. The x and y are still x and y. The m and the b have become numbers. But the really tricky thing, not just that we're treating those 4 letters not all the same, but that at some point in the process, what happened to the x and the y? What did they become? They became coordinates. They became numbers. And then they transported back to being letters, right? And so it's like these letters they just get treated very differently. Some of them become numbers and stay numbers. Some of them become numbers but then go back to being letters. And that's what makes it tricky, just in the beginning. But with practice, it's a fairly routine process. Okay, next page. There is an alternative to the y equals mx plus b equation. Here it is. We can also find an equation of a line using another method. Suppose a non-vertical line has slope m and contains the point x1, y1. The ones down here at the bottom, the subscripts, are just supposed to indicate that it's the first point. There might have been a second point someplace down the road, but it's just telling you they are specific numbers as opposed to the variables x and y. Those are specific numbers. Then an equation of the line is y minus y1 equals m times x minus x1. That equation right there, we'll talk about it, but it is just an alternative to the y equals mx plus b. It gives you the same exact answer at the end of the day. It's just another option for you. We say that this linear equation is in point-slope form. Let's see how we use that equation. We're going to find an equation for the line that passes through these same 2 points. It's the same problem we just did on the previous page, but the process will look a little different. By using the point-slope equation, that's that one right there. So first thing we're going to do is find the slope. Finding the slope of the line connecting 2 points is the same calculation we did on the previous page. It is still -3. Then we're going to rewrite your equation. It's the highlighted one here. And all we're going to do is change the m to the number that we just found. And the number that we found for m was -3. So everything else is copied. Just one small change. Lots of copying. Next thing we do is we change the x1 and the y1 to the coordinates of one of those points up there. And it doesn't make any difference which one you use. If you have 2 points, just pick one. So all we're saying is that the first coordinate here, the -1, is what's called x1, and the second coordinate is called y1. That's it. It's just notation. So what we do is we change the x1 to what number? -1. That goes right there. And we change the y1 to what number? 4. And it goes right there. That's it. Y minus 4 equals -3 times x minus -1. Okay? All we're doing is changing the x1 and y1 to the numbers, coordinates of one of those points. Okay, and now all we have to do is solve this equation for y. Here we go. Let's see. First, I know that subtracting -1 is really the same as adding 1. Yep, that becomes +1. What can I do with this -3 here? Distribute, so we'll distribute the -3 and get -3x minus 3. Trying to solve for y. How do I move this guy over? Add 4 to both sides, add 4 to that, and you get a +1. So we get y equals -3x plus 1. How does this compare to the final answer on the previous page? exactly the same. It's just an alternative. It's no better, it's no worse. Honestly, I think it's about the same amount of work whether you do the mx plus b or this guy. Just by a show of hands, because I know you guys have seen both of these equations before. I'm just going to ask you which one is your kind of more comfortable version. So raise your hand if the mx plus b is more comfortable for you. Good. Raise your hand if your preference is this one, the y minus y1. Yep, that's about normal. Is that most people like the mx plus b, and a couple of folks prefer the y minus y1. So on the homework, you are going to see some problems where it says use mx plus b, and you're going to see some other problems where it says use the y minus y1. So on the homework, I feel perfectly okay asking you to do each of them. But on a quest or a test, you get to pick. I'm not going to force you to choose one over the other. My strong preference is that you get really good at one of them at the complete neglect of the other. That's totally okay. I'd rather you be awesome at one than so-so at both, okay? So you're just going to pick one, but on the homework, I do want you to play around with both. Okay, so what we're going to do is work on the activity. I'm going to call us back together at some point during class, and we're just going to do the next demo as if it were the next class. You are not going to have time to do the entire activity, but let's see how far we get until I stop you.